Hello and welcome back to VitoshAcademy in the part 3 of the video where we are solving for the solutions of the Diophantine equation or Diophantine equation, depends who says it. So the equation is pretty much the following. Imagine that we had like a red t-shirts at $18, black t-shirts sold at $11, and the question was how many t-shirts could we buy with $1,188, and the answer lies somewhere around these numbers here. So at part 2 we had our big aha moment. We built our concrete solution function, pretty much this one here, and we fed it to our problem about red and black shirts, and it gave us an answer. So let's just repeat the answer. This is calling the Haskell compiler, and now the concrete solution pretty much of the shirt problem is this one. So let's look for it. Concrete solution of the shirt problem, and this is the answer, just minus 3,564 of the red ones, and the other ones are in positive. And you can probably understand that this one is actually totally correct, and I'm even going to check it because we also built a check function, check solution, and entering the numbers. Numbers are usually minuses in parentheses if they are with minuses, otherwise no. And here it would be like this, short problem, and it's gonna say true. And if we just change something like this, it's gonna say false. So obviously this is the check solution function here. So the thing is that this is a weird answer, a strange answer, not the best answer that you can imagine of this kind of question, because going to a shop to buy shirts and actually selling them is not a everyday scenario. Yeah. So the thing is, we know from part 1 of the series that 66 and 0 is actually something that works. Just to show what I mean. And it means that this is something, and we want some kind of a better solution. So the thing is, this would be like the last part of the Haskell videos. So the thing is that we don't have one solution, obviously. We have an infinite solution space, and today we're going to discuss not only about finding the single solution, as obviously we have found at least 3. We're going to build a solution factory. So we're going to write down a function that generates every single possible answer. And to do it, we're going to use one of the most powerful and fun features in Haskell, which is called infinite lists. I mean, Haskell can indeed make infinite lists. It can probably not just display them infinitely, unless you don't have infinite time, but it can do infinite lists. So talking about infinite lists and not showing them is not a good idea. So let's show them. Yeah, let's make a list with all the numbers infinitely from 1 to infinity. So how do we do it? Well, Haskell does it in its own way like this. And these are all the numbers from 1 to infinity in your screen. If you have infinite time, it will probably not stop. Let's press Ctrl+C. See, we interrupted the count to infinity, and we were into 42,217, which is good. And you can probably say, okay, what can you do with this kind of infinite list? Well, you can say take 10, and it's going to take the first 10 from the left side, never from the right side, because this is how it goes. Yeah. That's good. Let's apply this one to our shorts, if it is applicable, and I think it will be applicable. So we need to think about what can we do with our solution, which was this one, minus 3,564 and 5,940. And how can we get from this solution all the solutions that we have? Well, the math recipe is supposed to be simple. We have a solution of x and y. This is our x and this is our y. And the next solution is just a step away. So yeah, for the red shirts, x, the step size of the price, the step size is the price of the black shirts. Let me show it like this. Okay, so yeah. And the black shirts were at 18. Well, in this case it's 11, but consider it 18. And for the black shirts, y, the step size is the price of the red shirts, which is 18. Okay. Now I'll help you here. We'll simply say, okay, black here and red here, and everything is okay. So you are not mistaken. So to get 1, you just have to step with the other. So pretty much here we can just add 11 to x and subtract 18 from y, talking about this is x and this is y, and we'll have our new solutions. So let's see whether it will work. Minus 3,564, and if we add 11 to it, is this one, and 5,940. If we subtract 18 from it, yeah, we have this one. And it's a question whether these two would be working. How did we check this one? We had a check solution. And check solution was something like this. Let's see with the new ones. Minus 3,553. Comma. The minus is always like this. And then the other one was 5,922. Yeah, it works. So pretty much this is our way to get all the solutions. Just having one is a way to go, and then just going and having all the others. So the thing is that now we should build something that I already mentioned called a factory. So let's build it. Let's build this factory that actually produces all the solutions that we are interested in. And it will take our equation and it will return a list of solutions, and the list will be pretty much unlimited or endless in one of the solutions. So Diophantine LD2 is a Diophantine LD E2 A, B, and C, and it's actually kind of magic thing. Okay, so here we say case concrete solution. Nothing returns something, and then just XY that returns stuff. And I'm going to leave this here, and I'm going to explain it a bit more. So if there is no solution, we return an empty list. This is what we should do. But if we have a starting point here, we need to generate the rest. So let's define our step sizes here. So let D equals GCD. It's greater common divisor. A and B. And I think that we had this function from before. No. It's obviously some kind of a function that is then built in. Yep. And then here we should have, okay, no copilot. Step X said no copilot. No, okay, now I got it. When I'm typing pat tap, then copilot should be thinking that I want it, but I really don't want it. So step X is, yes, B divided by D, and step Y is A divided by D. This should work. Yes, we divide by D our GCD, so to say, greatest common denominator, just to be safe. Though, for example, here for 18 and 11 it is 1. So now let's go to the infinite part. We need a list of steps to take. Let's call the list of steps KS, so to say. And let's think how to do it. We're probably going to do it like this. So concat. It actually knows what it's doing. I am impressed by the copilot here. It's impressive. I mean, it knows what it does all the time. So yeah, for those who are not copilot people, like everyone else probably watching this thing, what this does is the following. It takes all the numbers from 1 to infinity, turns each one into a pair, so to say, k and minus k. So if we take like 7, it makes it a pair of 7 and minus 7, concatenates it into one big stream and puts a 0 into it. Let's actually try this one. Okay, yes, yeah, this is what it happens. Yeah, see, it put 0 and then it started 1 minus 1, 2 minus 2, 3 minus 3. Yeah. And now we're going to map this one over this infinity list. And how it is going to say and to look like. That's a good question. And let's see how it will work. Okay, so we have a typo here. Let should be like this, and the in should be like that. What else? Yeah, to Diophantine we give integer. Integer is a good one. Yeah. Control Y to continue with copilot. No, we're perfect. Well, not exactly perfect, as our nothing is not returning anything, but now it is returning an empty list. And here this in should actually be in something, and copilot actually knows what it's doing. Yes. Even gives us an example usage. I'm impressed. Yeah, anyway, let's give it a try and see what will happen if we take 5 of the Diophantine, reload, Control S, reload. Let me copy the code I have already, and I'll just reload it here. Something is trace, yeah. What exactly is changed? Yeah, don't see anything changed, but let's go with the new code. Yeah, and see whether the reload will work. Yeah. What was the difference and the problem? Well, it was somewhere here with the GCD and the formatting, I guess. If you see the difference, write it in the comments. And yeah, I would appreciate if someone can say, hey, Vitosh, this was the difference. You should have done that. Yes, not joking. Take 5. Let's continue Diophantine and short problem and see what's going to happen. Well, it happened. We started getting our thing. Yeah, each one of these is a solution. Each one of them is not a fancy one, still negative, but it is working for sure. Now what we can do is we can use filter. So from all the solutions of the short problem, we only want to keep these that are actually positive, where red is positive and black is positive. So let's write something here. Red is positive. I'll use red and black, not anymore X and Y, and red should be bigger than 0 and black should be bigger than 0. And then filter is positive. Diophantine short problem. And I'll just copy this, reload that. And okay, this one is like that. Save and then do it like this. Then what happened again? Parse error. Okay, reload. Now it's working. And I said filter is positive. Diophantine short problem. And these are all positive results, which is something. I'm seeing that it somehow stopped, so I'm just pressing Ctrl+C, interrupted. Yeah. But these are our results. I'm not sure why I had to interrupt it here. Probably I have not defined something fancy like show or something like this. And after all, we are filtering on an endless list. In a way, if you know which is the endless list, write it in the comments. If you don't know, don't write it. But pretty much the idea is here saying that we can buy, let's say, 0 and 108 shirts correspondingly, but these are all the values that we are interested in. Let's give it a try and check it. Check solution. Then we use 1190. And the problem is short problem. And it's true. And if we just check it for the negative thing, yes, it is false. All these add exactly to 1188. So we started with the math problem, just remembering what the math problem was. The black t-shirts were $18, the red t-shirts were $11. The question was, how many can we combine with 1188? We modeled this problem with types, with data, with type solution to. We solved it with an algorithm, which is probably more than 2000 years old. And finally, we used infinite lists to list every possible real-world option. And every possible real-world option was here, only for giving red and black, so to say, and using filter. Yes, so Diophantine should probably give us endless thing. yeah, the Diophantine gives us an endless thing. If we take, for example, not 5 but 500. Not sure why my computer is like reloading like this. Processing stuff shouldn't be happening, but sometimes it happens. Okay, anyway, this is what we did. We started with LD2, pretty much saying this is linear Diophantine equation where we have the 3 integers. Then we went to the type of the solution where we only have the 2, the red and the black t-shirts. We went through pretty print, which was in the first video. We had an option to check the solution. Then the simple problem definition, which was, if you remember, this one here, and the solution was 1 times 3 plus 4 times 0 is 3. Then at the end, we went all the way showing that the interesting Diophantine solutions are this one, and when I say the interesting one, I mean the one that are actually you can go into a shop and buy positive or 0 shirts, but not negative, because negative is obviously selling something. Okay, so that's the power of Haskell. I'll be making more Haskell videos. They would be hopefully more interesting than these 3 ones, but still I would be curious to see your opinion about them. So enjoy the rest of your day, take care of yourself, and see you next time. Goodbye.